Hello, welcome to the very first lecture video for Math 46. Today we'll be covering Chapter 1, Section 1, so looking at the decimal place value system. Before I begin, I just wanted to mention that Chapters 1 and 4, which are the first two chapters we cover in this course, are designed to be covered at a review pace, so I'll be going through them fairly quickly. We're going to be looking at, in Chapter 1, operations with whole numbers, and then in Chapter 4, doing the same thing but adding in decimals. If this does not feel like review, I'm probably going to be moving too fast for you. So if you feel that that's the case, please have a conversation with me so I can help you with that. All right, so the decimal place value system. This is the system that we use in our current culture. And it's a base 10 system. Has anyone ever thought about how we could have ended up with a base 2 system like they have in computers, or a base 8 system? But we have a base 10. A student told me it's probably because we have 10 fingers. And I would agree with that. I think that might have something to do with it. So let's take a look at what we have. So first of all, I'll just draw your attention to this decimal place here. So anything to the left of that decimal place is talking about wholes of something. So if you're one digit to the left here, we're talking about ones. Okay, so let's say we're talking about cups of flour. We have 1 cup of flour. If we move 1 digit over to the left of that, now we're talking about tens. So for every value in that position, that represents tens of cups of flour. Okay, and then so on. So we've got hundreds. These are all kind of the ones, the yellow ones here. Then we get into the thousands. So after ones, tens, and hundreds, now we're talking about 1,000s. Okay, then tens of thousands, then hundreds of thousands. And then we get into the millions and billions, which go in the same sort of fashion. To the right of that decimal place, we have something similar. So tenths, if we have a number in there, it represents the number of tenths of the thing. So we're no longer talking about whole cups of flour. Now we're talking about part cups of flour. So if you have a 1 in that position, that's saying 1/10 cup of flour. And we'll talk about this more when we talk about fractions too. But that column is going to be your tenths. Over to the right of that column, we're talking about hundredths. So note the THS, so that's different than hundreds. Here we're talking about hundredths. So if we had a 1 in this column, we're talking about 1 out of 100. If we divided that cup of flour into 100 equal portions, 1/100th, the one that would be represented there in that place value, would represent 1/100th, one portion of that cup of flour. Okay, so we've got tenths, hundredths, thousandths, 10,000ths, and 100,000ths. So as you'll note, as you go from the right to the left, every time you jump 1 over to the left, we're multiplying by 10. That place value represents tenfold more. It represents 10 times as much stuff as the one to the right did. So as an example, let's just look at the place value of each digit in this number. So they've given us this number here. And what I like to do first is just kind of orient yourself by where the decimal is. So here's the decimal. Here's our number. They've written it down here for us. Okay, so we're going to put our decimal there. And then we can start, let's start with the whole numbers. Let's start with the numbers to the left of that decimal. So we've got 295, so 418, and then 295. Sometimes, especially in handwriting, you'll see they write a comma between every 3 digits. And then from there, so if we go from our decimal place, we can label it as you see above in that chart. So we've got the ones. So here we're talking about 5 ones, 9 tens, 2 hundreds, 8 thousands, 1 10,000s, and 4 100,000s. As you go to the right of that decimal place, then we're going to be talking about tenths. Okay, so parts of a whole, hundreds, and then thousands. So based on where that decimal place is and how far to the left or right of it you are, you can identify what place value you're talking about. So for example, let's try to write the word names for these numbers. So they've given them to us here, but let's take a look. So we've got this number here. Okay, and so there is no decimal here, which means that you can assume the decimal is right here to the right of the 5. So that means this is our 1s, our 5s. Then we've got our 10s, 100s, thousands, and then 10,000s. When you go to say this word for this number, we're going to do it in the chunks, kind of like you see colored here in different colors. So if we look at this, it would be what we saw in green up above, this 27. Those are our thousands. So we have 27,000. And then up here we have those ones, the 3 digits that represent the ones in yellow. So we would say 27,000 and then 345. Okay, this next example, they've gone even further. So now we've got our 3 ones here. Then we've got our thousands. These 3 digits are going to represent our thousands. And then we have our millions, which are shown in blue. So let's put blue here. So if we were going to read this one, then we would say 72 million for those blue numbers, then 358,000 for the greens, and then 694. Last example there. Why don't you pause the video and see if you can figure out that one without looking at the words. Okay, and so hopefully for that last one, you said, well, the first 3 digits represented the ones, and then the next 3 digits over from the left represented the thousands. So this would be 503,238. Let's do one more that's not right there in front of you. So I'm going to write a number in here. Here, let's make it a little harder. There we go. And I'd like you to pause the video and see if you can figure out the word name for that number. Okay, and so hopefully you took a chance to do that. And so you'll say, well, those 3 digits are the ones. And then we've got our thousands here. And after thousands comes the millions. So this would be 1,487,000, because those are our greens. And then 500, I guess there should be a comma there, 507. Okay, let's do something a little different this time. So now we have this number here, which would be 6,831,425,097. Let's say we have this number and we want to figure out the place value of the 2. So where's the 2? Here we go. So here's the 2. So if you look back at that chart, you'll see that 2 represents the 10,000s because it's 5 to the left of the decimal. Remember that if there's a decimal on a whole number, you can imagine it's right here to the right of the number. So this is the 10,000s place value. Okay, place value of the 4. Here's the 4. So that would be 100,000s. So go ahead and pause this video and see if you can figure out those next 2. Okay, let's do those next 2 together now. So the place value of the 3. So here's the 3. So we were dealing with ones, then thousands, and then this is millions. So that middle digit in the millions then is going to be 10 millions. Oh, I'll do that in yellow. 10 millions. And last one there, we've got 6. And so that's going to be the billions. Okay, let's do some more words for each of these numbers. So first ones, we're going to say, well, these are our ones. And these are our thousands. So if we were going to write that as a word, then we would say 658,000. And then we've got our ones, which are 942. We don't really say 942 ones, but that's what we mean. 942. Okay, go ahead and pause the video and try that next one. All right, and let's do that one together. So this last one should be 2,000. 305. 3 helps if you can spell. 305. Now, most people say they would say 2,305. I'm not fussy. I think that's fine. Technically, there is no and in here. You don't have to say the 305. But we tend to in English. Okay, last bit here is just talking about standard form and expanded form. So standard form, this is kind of like, I'm going to call that the regular numbers you see. Regular numbers. Expanded form is kind of showing that you can interpret those numbers and understand what they mean. So if you look at the normal standard form number 273, well, what does that really mean? Well, what it means is you have 2 hundreds. Okay, so you're taking 2, multiplying that by 100. That's why it's represented in the hundreds column there. Plus, you have 7 tens to represent that 7. Plus, you have 3 ones, because all together, that's how you end up with 273, right? Or if you want to think about it backwards, you have 3 ones, and then you've got 7 tens, and then you have 2 hundreds. So that's the expanded form. It's kind of just showing you can interpret what the number actually means. So if we were to write 593 in expanded form, well, the 5 is talking about hundreds. That's in our hundreds position. So that's going to be 5 times 100. Then we're adding, our nines column is in the tens position. So we're adding 9 groups of 10, 9 times 10. And then we're adding 3 ones, so 3 times 1. And if you were to plug that into your calculator, you would get the same answer. You would get 593. It's just an expanded way to write it. Okay, last one we want to write in standard form. So they've given us a word and they want it in standard form or normal form, regular form. So 23,709. Well, we're starting with the thousands. So we know that's going to be in that second group, in that green group we were talking about. So 23,000. And then we've got, I can't remember what color I am on. Then we have the yellow, which is our ones. And we have 709 of those. So we have 700. Here we don't have a tens group, so we just use a 0 to kind of hold that place to show there's 0 groups of 10 in this, plus another 9. So our number would be 23,709. Now it's written in standard form. Up to you. If you want, you're welcome to write a comma here. Often when we handwrite things, we write commas, or you can just leave a space. Now that we use computers more, we tend to just leave spaces. So either way would be fine. And that's the end of 1.1.